Hello and welcome to the NXP and Future Electronics collaboration webinar on the future of facial recognition with MCUs. The agenda for today is that you'll get a presentation and then we'll show you a live demo and we'll do a Q&A at the end. So in the meantime, as you follow along, please feel free to type in your questions into the question box on your GoToWebinar panel, and we will save them all for the end for the Q&A. So without further ado, let me hand it off to Bill.
Welcome everyone. Thank you for joining our webinar today. So today we will be discussing facial recognition with MCUs. Today's presenters and participants that will be supporting not only the presentation but answering questions is myself, Bill Pratt. I'm the Regional Sales Manager with Future Electronics, and I support the Western North America region. Also on the call with me is Don Gunn. He's our processor specialist with Future Electronics. He will be doing the demo. And then from NXP, we have Rick Bai, who is the IoT Solutions Senior Product Marketing Manager. And Rick will be supporting us and answering your questions at the end of the presentation. All right, to kick this off, we're going to give you a little bit of background about Future Electronics, who we are, as well as the group that I represent, which is Future Intelligent Solutions. Then we'll move quickly into an overview of the RT processor family. And then we'll talk specifically about the i.MX RT106F facial recognition platform. And we'll go into details about the benefits of this platform. We'll discuss briefly some anti-spoofing with liveness detection that is now available with the i.MX RT106F recognition platform. And then we'll have a few slides about utilizing transfer learning. So you can utilize the 1060 platform to be able to create your own specific classes. Also during this presentation, we'll be doing a live demo that Don Gunn will be providing that will show you how to be able to utilize the platform, not only from registering an individual, but the ease of use of the software. So a little background about Future Electronics. Future was founded in 1968 by Robert Miller, who is still the active president and chairman. The company is privately held, financially stable, debt-free, and virtually 100% organically grown. We operate in 44 countries, and as you can see, we have 5,500 plus employees, with 2,500 of them being customer-facing with our both technical and sales resources. We also have 1,000 plus marketing and purchasing executives that are aligned by technology, so they're very well versed in those particular technology areas. Future is a leader in global supply chain solutions with a single global IT and CRM, which is a proprietary platform for real-time inventory data. So Future runs on an inventory-driven model. That is our way to actually conduct business very effectively with our end customers. The worldwide headquarters is located in Montreal, Canada, with regional headquarters in Singapore and Engham, UK. The Future Intelligent Solutions business unit, which I am part of, is a group of engineers and sales professionals that focus on higher-end FPGAs, microprocessors, single-board computers, as well as networking and high-performance interface products. As you can see in our pyramid on the left there, we offer support to our customer-facing field resources to provide a next level of technical expertise in supporting your end design applications. So we have expertise in embedded systems and Linux implementations, communication as well as application processors, FPGAs, high-speed networking, signal integrity, as well as the up-and-coming AI and machine learning, which really is being emphasized in this presentation. So let's talk now about the i.MX RT processor family. The i.MX RT is a crossover MCU. So the crossover embedded processors are targeted for consumer, industrial, and the growing IoT application space. It delivers the performance, functionality, and capabilities of an application processor-based design, but with the ease of low power, ease of use, and real-time operation with low interrupt latency of an MCU-based design. So a very versatile processor that bridges that gap between the lower end MCUs and the high performance application processors. The i.MX RT series is comprised of these different processor families within this product group. So it's quite scalable, as you can see, with on the lower end with the Cortex M33 with trust zone running at 250 megahertz, all the way up to a M7 with a 500 megahertz core, on M7 with a 600 megahertz core. Then at the very high end, we have the i.MX RT 1170 with a 1 gigahertz Cortex M7 core, which is very unique in the industry. And as you can see on the bottom there, how they are pretty much segmented within this product group. The i.MX RT 1060 is what the i.MX RT 106F facial recognition platform is based off of. So as you can see here, crossover processors such as the RT 1060 are built using application processor chassis. So delivering a high level of integration, high-speed peripherals, enhanced security, and engines for enhanced user interface, but powered by a low-power MCU core running a real-time operating system. So as you can see here, a very flexible platform that is now being utilized to implement facial recognition algorithms. The RT series Enable It overview. So design and enablement, specifically software tools, are one of the most critical aspects for selecting and developing a solution. NXP provides all the enablement needed. Its comprehensive enablement allows you to get started quickly and efficiently. It includes MCU Expresso, which provides a unified IDE experience across the NXP portfolio, as well as the MCU Expresso SDK, which is also supported by IAR and Kyle. And as we had mentioned, the i.MX RT series is that crossover processor. So it allows you the performance and capabilities and integration that will bridge that gap between an MCU and an application processor, giving you the lower bill of materials cost, as well as the lower cost of programming with off-chip memories. So high performance memory interfaces. This really allows you to lower your overall bill of material costs, but also provide that performance that you're needing for your end application. Now let's talk about the secure face recognition solution, which is based on the i.MX RT 106F platform. So a little bit of background about facial recognition, and many of you are probably aware of this. Facial recognition was pioneered by Bledsoe, Wolf, and Beeson. It actually started in the mid-60s that this team started to work on using computers to recognize human faces. As this started to progress, development was quite slow through the 70s, 80s, and 90s. And then in 2006, there was a face recognition grand challenge. This really allowed the development to grow significantly. And they were seeing new algorithms that were 10 times more accurate than the prior facial recognition algorithms. Then in 2020, NXP really created a platform that allowed individuals to take a very low cost, high performance, low power MCU and use this to be able to do your facial recognition. This is a significant breakthrough in this application area. And what they provide is a solution that is production grade. This is certified system solution implemented using the best in class silicon with the i.MX RT 1060, software and IP from NXP as well as from third-party partners. NXP delivers near production ready hardware that is cost and form factor optimized with pre-integrated and fully tested and certified software. So you truly get a plug and play out of box experience with this platform. And this significantly shortens your time to market with this particular solution from NXP. So the portfolio is based on already released in Q1, a local face recognition solution. This was based on a single RGB camera. This provided a very low-cost, high-performance facial recognition platform that could be utilized to immediately integrate these features into your end products. With feedback from the customer base, the engineering community, they understood that they needed to create a platform that allowed them to have secure local face recognition. So this allowed them to do liveness detection for anti-spoofing. This is a significant advancement, and this is launching this quarter. So this also has with it a dual RGB and infrared cameras, allowing that anti-spoofing feature. And as what we get from this is we have a full secure face recognition platform. So liveness, detection, which is very much needed for secure access, so e-locks for say. If we want to make sure that it's not the individual trying to gain access is not using a photograph, then this is a great way to be able to discern from that particular type of access. Also with the IR camera, it is great for nighttime, so low light applications. And this is a full EdgeReady solution that will significantly reduce your time to market for your product. Here is the block diagram. I believe what we have to take notice of here is the cost of the major components within this block diagram. On the right-hand side, you will see that we have the i.MX RT 106F MCU cost based at 100,000 units resale, and then the major components there having a total bill of material IC cost of approximately $8. This is very low cost point to be able to add such a high performance facial recognition solution to your end product. And the RT106F solution is built around NXP's proprietary Oasis software. So the Oasis Lite runtime library is an inferencing engine that provides this high performance facial recognition solution that's able to run on a Cortex M7 core. So at the heart of the facial recognition solution is obviously this production ready software. So out of the box, you have software that is ready to move into full production. So it's optimized to run on the RT106F, but leaves headroom for the CPU for customers yourselves to run other control functions. So running on FreeRTOS, this solution also reduces that overall cost to be able to bring a product to market. So there are two different model types to support. So they have a light model, which supports up to 1,000 RGB faces and 50 IR faces, but you can see the time for facial recognition is less than 500 milliseconds. And then they have a heavy model. So this is a very large database, which would have support for 3,000 faces and 100 IR faces. The facial recognition time is a little bit longer, but still a very high performance platform. So the Oasis recognition software pipeline is broken up into 3 different feature sets. On the input side, it's about capturing the image, making sure that the image from the CMOS imager is captured properly. It's provided to the image pipeline, and then provided correctly to the Oasis Lite runtime software package, which will do the face detection, identifying that there is a face in the field of view. And it does some other quality checks, such as the face quality check, the glass detect, and also making sure that the face is aligned properly within the field of view. And then it will do the facial recognition. It also has added features, which we'll discuss in a few slides here, of being able to do face feature recognition. And this can be used for a number of different applications, which we'll touch on shortly. And then also it's able to do the face recognition display and update to an LCD if you had an LCD locally. The solution performance is significant. So not only does it deliver a very high accuracy and low false acceptance rate, and a high rejection of spoofing, it's fully optimized application, from a low-cost perspective. So utilizing low-cost imagers, you can detect subjects within 1 meter. So this is very significant to understand that not only is the performance as well as the accuracy, but the actual cost to be able to move this to market is very attractive. So let's talk a little bit about the emotion recognition. So here, what we're able to do is have 2 different emotion classifiers. We have a 4 emotion classifier as well as a 2 emotion classifier. So this allows us to be able to, detect the face in the field of view, and then understand what the face is displaying from an emotion standpoint. From a 4 emotion classifier standpoint, we have angry, smile, surprised, and neutral. And then the 2 emotion is just smile and non-smile. But you can see the inference times are very fast. So this is a very useful solution when you're doing retail space analysis. Now, also, what is available is the capability to do remote registration. So NXP provides an app, it's an Android-based application that allows you to register a face utilizing a cell phone. So you will connect via BLE to the 106F platform, and you can add and delete users as needed. So this is great for being able to register users for, let's say, access to a gym facility, or to be able to set up equipment for a user to use in an industrial space. So this is a way to easily create a platform that's deployable from a remote standpoint. But also it can be utilized even further. So not only can you create the individual's image remotely on an Android device, but you can also do this on a PC-based platform and then send this over Wi-Fi or BLE, whatever, to your end access control system. For instance, here they're making reference for door access and smart e-locks. So it's an easier way to be able to register the individuals. Here's a number of the use cases and target applications. So secure access, obviously, probably one of the larger user spaces for this particular platform, but also user authentication. Let's say, for instance, we wanted to create a secure access to a cooktop so children would not be able to gain access to the cooktop. This way, avoiding any unforeseen accidents that may happen. User identification, being able for, let's say, an industrial environment, making sure that the correct individual has access to utilize a CNC machine, let's say. Or user customization for setting up the lighting controls in a meeting room, or for setting up a piece of fitness equipment to that particular user's profile. So in a gym, the user could step onto a treadmill. Their trainer would already have the profile set up. It would identify their face, and it would take them through a workout routine. So, but also the emotion detection that can be very valuable within a retail space standpoint. This allows you to be able to understand how different retail displays are actually being received by individuals that walk by. So you can get an emotion feedback, or how is an individual actually engaging with an individual during a sales process. Make sure that, during a sales process, the customer is happy with the experience. So a lot of end use applications for this particular platform. So right now, we'd like to turn it over to Don. Don's going to give you an overview of utilizing the RT106F platform. Don?
All right, thank you, Bill. Okay, so thank you, Bill, for the description of how it all works. I just wanted to take a moment to actually show everyone the camera in action. Actually, maybe I'll just. So this is the board for the camera or the recognition system. So we have the i.MX RT down on the main board, and then we have a daughter board up top here, which has the camera connectivity and some LEDs. You can see up at the top here, these are IR LEDs that are being picked up clearly by the camera on my laptop. So what you have here, you've got a USB Type-C connection on the board. You just plug that into your computer, and you can select it comes up as a camera, USB webcam. So in this case, I can just hit switch cameras on my laptop, and I'm now looking at the camera from the eval board. So the first thing I'd want to do is I want to register a face. So you'll see on the left-hand side, I've got a terminal window open there, and I can just say add, and I'll add myself, and you put a name of the person that you want to add, and then it starts registering. So it's added me as a user. So I can, in the terminal window, I can hit save. And now if I reboot the camera, it will still recognize my face. So now it looks at me and it says, okay, unlocked, welcome home. Now Bill was describing the IR camera versus the RGB camera. So in this shell, the demo runs free RTOS. So you have a number of commands that you can use. If you type in help, it gives you a list of the available commands. And in this case, we'll just switch over the camera to the IR camera. And that's, we have a command here, the display output mode, which we will edit. And we'll change it to IR. So now you'll see that this is the IR camera operating. Still recognizes me as a user. Significantly different output to the inference engine though. And this can be used, this is used in the liveness detection process. And I will switch it back to the RGB camera just to give you an example of the difference. I've got a picture that I just took of myself on my cell phone to try and fool the system. So if on the RGB camera, you can see my picture fairly clearly. But if you switch that to the IR camera and try to do the same thing, that is what you see on my phone. So that's obviously that would not be detectable and improves for this spoofing process. So like having a camera on your phone or a picture on your phone to just try and fool the system would not work. And as Bill mentioned, there's also glass detect, so it will detect that you've got a glass surface instead of a real person up next to the camera. Just to go through some of the options that are in the eval kit. List, this shows all the registered users. So in this case, it's just myself. And then you can add a user or delete a user. And then the default is that it will save things. If you register a new user, it'll be in SRAM. But if you want to save it to the flash, you just type in the save command, and that way, when you reboot the camera, the name will be there still. Also, you can control the LEDs on the board. There's some white LEDs and some IR LEDs that are PWM driven, and you can set values for those to increase the light brightness to improve the recognition. So that's controllable by the user. And then also there's a firmware update process that can be used. There's a number of different ways of updating the firmware, either through a debugger or through Wi-Fi, or using it as a USB mass storage device, so you can just download new firmware over USB connection. Also, you can turn on the emotion detection, so we'll do that. So we'll try the 4 emotion setting, and then it'll give us an indication of. Actually, sorry, let me just change the app type. So if I'm in a good mood, it tells me I'm happy. If I'm in a bad mood, angry, etc. So it'll give you kind of an indication of what mood the person is in. And then you have some configuration. You can select the camera that you're displaying. And then also there's an optional display that you can get that will connect up to the board. So you can decide whether you want the display to be on the via USB as a webcam, or using the EdgeReady display that's been tested with this hardware. And then there's a number of options here for configuring your Wi-Fi. So you can connect the board up to Wi-Fi and up to do your updates, or connect to it through a variety of means. So that's kind of an overview of the of how it works. Okay, so the actual development is done through the IDE provided by NXP, MCU Expresso. And as Bill mentioned, this is a common IDE across the NXP platform of devices. In this case, I've already imported the SDK for this board. So it's the SDK SLN Vision AS-IoT. So that is now in my system. So you can then import examples from that SDK. So we'll choose the board that we're working with here. Hit next, and then you'll see that there are a number of application examples, and this is sort of the complete set of code that is on the board when you first get it. So we'll select all of these. I've already gone through this process, as you can see on the top left here. These are all already imported, so I won't actually import that at the moment. But the main application is this SLN VIZNAS IoT ELOC OOBE, so the out-of-box experience. And you've got all your source code in here, so that if you want to make some modifications and use this as a starting point for your application, you can. And you can. There's a number of different options. For example, if you need to control the LEDs to come on and off automatically to improve your facial detection, or which camera you're using, or set up the Wi-Fi, things like that. So you can configure everything on the board, and then also add in some code to actually take the appropriate action when a certain situation arises. So if you detected a recognized face, you could trigger an unlock function, or whatever the situation may be. So that's kind of a high-level overview of the board and how it works. And I will turn it back over to Bill to kind of carry on with the presentation.
Thank you, Don. Sorry about that, just waiting for control to come back. All right. Make sure. All right.
There you go.
Thank you, Don. I wasn't certain which one was showing. I apologize for that. All right, so the board that Don was demoing was this particular platform, which is the dual camera adapter platform, which is a combination, as Don had mentioned, with an IR as well as an RGB camera. So the advantage of this, when you're looking for liveness detection, is it is at a lower price point than a 3D time of flight solution. So allowing you to reduce your overall bill of materials. And this, liveness and anti-spoofing capability is designed for consumer security applications. So this defends against such as color or grayscale pictures, like Don had mentioned, whether there was a glass in between the individual and the actual imager. So this provides a consumer level category of security. So it is very good from that standpoint. Also, with the IR camera, you get that good nighttime capability. Many of the times for EWOCs, individuals may be showing up at the location and it is dark outside. So this will still provide a solution for your end product. A little bit of background on the liveness detection. As you can see here, there's a number of safety solutions or checkpoints that are made throughout identifying whether or not the individual is, a live individual and not a photograph or a picture from a cell phone. And it goes through a number of checks before you actually have the liveness pass. So this allows you to understand that there are a number of different checkpoints within the liveness detection that make sure that you do have a consumer safe security access product. So as we said here, supports day and night time from a liveness mode, supports the anti-spoofing, so screen photos, printed photos, etc. And there is a time of flight 3D camera in development. That will be the next release here for those that are looking for even more advanced secure solutions. And Don had showed you, so the liveness detection for anti-spoofing, it protects against picture-based applications. So you see the photo there. It's not going to allow that individual, based on showing a photograph, to gain access with this particular platform. And the same goes for showing a photo from a cell phone. So a very robust consumer-based secure access platform. So we did the platform demo. Right now, we want to talk a little bit about transfer learning. So the RT106F is based on the RT1060 processor. So you could actually utilize that processor and do some transfer learning. So this way, you could take an existing model and be able to retrain some of the custom final layers. Because most models, the first few layers are basically identifying, specific blobs, color blobs, texture maps, and it's not particular to any data set, or they're basically general in what they do. And since it's very hard and time consuming to build a full custom model, what we can do is, and NXP can assist as well as Future Electronics, is walk you through on using an existing pre-trained model as your base, and then just change the last few layers. Since the model has already been developed to identify objects, we can reclassify the final few layers to be able to classify on an image set that is custom for your end application. So the reasons for this, as I mentioned, it really allows you to speed your custom model time to market. We don't have to start from new. So for instance, if a particular model was trying to detect the differences between boats and cars and bikes, we can actually use that model to be able to, possibly discern between a truck or a particular car. So it really allows a lot of flexibilities. And this, you can also reduce the number of classes being detected. So you can take a model that has the capability to detect 30 classes and actually retrain it to only detect 20 objects or 20 different classes. This would not only increase the performance of your model, it would also create a smaller model, for instance. So what we did, Future Electronics, we took the RT1060 EBK, and what we wanted to do, based on the current environment, from a public health standpoint, we wanted to retrain an existing model, which was MobileNet, is what we use, to identify whether or not individuals were wearing a mask or not wearing a mask. And we felt this was a powerful model to be able to design, because it was something that, within consumer retail spaces, they were looking for a way to be able to protect the people that were entering their premises. So since the inner layers are kept the same as they were from the pre-trained model, we only had to retrain the final layers of this particular model. Here is a short video that kind of gives an overview of how this works. In the lower right-hand corner there, you will see, this particular system running through the process. It will give you the inferencing time as well as the accuracy. And you'll notice in the video, he'll remove his mask now, and then we will see that it will show that we have a no mask set. And like I said, we took an existing model, and we just retrained the final few layers, and we used this with photographs that we pulled from the web. So they were open source. So this was quite easy for us to do, and we would definitely like to engage with you to show you how you would be able to do this in your application as well. That concludes what we have to present. I will turn this back over to the moderator and open it up for questioning.
Thank you so much, Bill and Don. So first, I'm going to launch a poll just for the folks on the call. If you're interested in having a follow-up and you want to know a little bit more, go ahead and click on yes. And Bill and Don can set up a call with you later. And while I leave this poll out, I'm going to start asking you some of the questions that came in, okay? So first one, is the external SD-RAM required to do the inference, or is the onboard RAM enough?
Yes, I'll take this one. Yeah, we do require a minimum of, I think, 8 megabytes of external SD-RAM to do the face recognition with the liveness detection. If you don't need the liveness detection, there are certain use cases where you can do face recognition with the i.MX RT106F without SD-RAM if you've got lower resolution images, but otherwise you need it. It's a pretty inexpensive component. I think it's less than $1 in volume.
Thank you so much, Rick. By the way, that's Rick, the product manager from NXP for this device. So next question, do you have rock curves? Is it possible to change the threshold for matching?
I'm not sure I understand that question. Bill, Don?
Same here, Rick, but we can definitely investigate that question and do a bit of research and get back to you.
For sure.
That sounds good. So, Casey, we have your contact information, and we'll get back to you with an email answer. So next question, is this product automotive grade?
No, the RT1060 family of devices are not automotive qualified and will not be. But Bill did mention during his presentation that NXP is working on a 3D or a face recognition solution that uses a 3D camera, actually a 3D structured light camera initially. That will be on our next generation RT platform, the RT1170. That was announced a while ago, but there'll be more information coming on that, and it will begin making that new RT available soon. And that device will have not only commercial and industrial temperature versions, but it will also have automotive qualified versions available. So we'll be able to, in 2021, we'll be delivering face recognition solutions on automotive qualified devices from the i.MX RT1170 family.
Fantastic. So next question, would this device work if the camera is looking through a window?
Probably.
Depends on the
I
clarity
haven't
of the
tried
window.
that, yeah.
All right, one more thing for you to try out. So what is the frame rate of the RGB and IR cameras, if you have that information available?
Not off the top of my head. I think it's about 30 frames per second, maybe 15.
And then why is the number of faces in memory for IR much lower than the RGB option?
Yeah, I don't know the answer to that question. Sorry. We'll get back to you on that one.
No problem. So do you know what's kind of the minimum distance between the camera and the person for the system to work properly? Like how close can you get to it?
It's typically between 30 centimeters and 1 meter, so between 1 foot and 3 foot kind of range. Any less than that and you'll be too close, your face will go beyond the field of view. And if you're any further away than that with the sensors we're using and the lensing, then the size of the image on the sensor will be too small. We need at least like 80 to 100 pixel height for the face image. So yeah, that range, so 1 to 3 feet, 30 centimeters to 1 meter.
Yeah, so I guess the different different lenses can be applied to optimize for distance, correct?
That's right, yeah.
So depending on whether you want to be closer to the camera or be further away, just change the focal length of your lens.
That's a good lead into the next question. Can we use our own camera, like an HD camera, to increase the working distance?
You need to use similar sensors to what we have in our reference kit, but you don't necessarily need to use the same identical sensors, but sensors with a similar interface and a similar resolution. So we're using on-semi sensors. There's a Chinese company, Galaxy Core, that has similar sensors that can be used, but yeah, you couldn't use, for example, MIPI interface sensors because the RT1060 doesn't support that type of interface, whereas the future parts, the 1170 does. So you need to be careful about what sensors you use. You can't use anything, but what we're using are very inexpensive.
All right, thank you, Rick. Next question. We have an i.MX RT1060 EVK kit. Is it possible to get the face recognition code to experiment with?
The face recognition code that runs on our SLN-VIZNAS-IoT kit will only run on the RT1060F version of the 1060. It will not run on an RT1062 or an RT1061. The RT1060F includes a license to use NXP's face recognition software. So there's an extra cost associated with that software that's built into the price of the chip. Therefore, it cannot be run on a standard 1062, such as you would find on the standard 1060 EVK. I'm sorry. So if you want to play around with it, you can buy the development kit for face recognition from NXP.com, from authorized NXP distributors like Future, and also e-tailers as well.
I think maybe the demo that Bill showed with the mask detection, that was done using the 1060 eval kit. and there was some algorithms implemented. It wasn't the same code as that's running on this kit, but if anyone has questions on how they can do some detection on the 1060 kit, then Bill and I can help with that.
Perfect. Good. So take advantage of the opportunity to talk to Bill and Don afterwards. And okay, I'm getting a bunch more questions, so we'll keep going. Is it possible for this to read license plates or do some kind of license plate recognition?
So the face recognition solution is optimized only for face recognition. I mean, underlying the face recognition application is a machine learning, machine vision application. And part of our longer term plan at NXP is to leverage that same vision inference engine for other machine vision applications beyond just face. So yes, it could be used for, there's a potential that we could enable customers to use a similar platform for things like license plate recognition or object identification, distinguishing between oranges and apples and bananas or whatever, but that isn't here yet. What you do have perhaps in the available now is what Don was showing with, Bill and Don was showing with the mask identification, and that's using a tool set from NXP, a machine learning artificial intelligence tool set from NXP called EIQ that runs on a variety of NXP platforms, including the i.MX RT, as Future was showing, and that's a tool for developers that have some experience, some knowledge in the area of machine learning, and maybe already have some models and some capability, perhaps on a PC environment that you want to bring over to an embedded platform like an i.MX RT. So that tool set, which is freely available, can be used for that if you already have some experience, whereas the face recognition solution we're offering on the i.MX RT 106F, it can be used by anyone, but the primary purpose of it was to enable people that know nothing about machine learning, nothing about face recognition, to add that capability to their products without needing any experience or knowledge.
Great. And so is this solution able to detect more than one face at the same time?
Not at this time, no.
All right. Can we add thermal imaging array sensors to the MCU?
Separately, yes. Obviously there's interest in this, checking people's temperatures. And so with a thermal sensor, you can check someone's temperature, and with face recognition, you can match temperature to a name and keep track of people's temperature over the course of a number of days. So yeah, that can be done with the RT. I've seen it done.
Fantastic. That would be very useful right now. And so next question, what is the robustness regarding face orientation?
So our face recognition engine can tolerate some misalignment, but really less than 30 degrees. Any more than that, maybe even less than that, and you'll run into difficulties. I mean, as Bill showed, we do some realignment, but it can only do so much.
That makes sense. Does this run entirely on the M7 processor, or is there a neural processing unit hidden somewhere?
No, this runs entirely on the Cortex M7 CPU. There is no kind of accelerator, no image processor, no neural net accelerator, nothing on the chip or in the system anywhere. There's nothing done in the cloud either. It's done entirely locally, so no images are ever sent to the cloud at any time. Bill showed the remote registration capability that we have, where you can use an Android device and sooner a Windows or PC-based device to create models, but in that case, you're only sending a model over the network. You're not sending someone's image. So we're really sensitive to people's privacy concerns with things like face recognition. So face images never leave our devices.
If anybody's interested, at the end, I can do a demo of the orientation capability, how far you can go over, turn things around with the actual eval board here.
That's great. Does that take a long time? I can change you over to the presenter and you can set it up, Don.
Sure, I can just do it right now if you like.
Yes. So you'll pop up to present. We only have about 2 more questions, so I'll ask, or actually first you show the demo.
So I am registered as a user. It's having a hard time. And there I'm unlocked. So that's almost 45 degrees.
Yeah, that's better than I said.
So yeah, but a little over 45 degrees in each way, each direction.
Thanks, Don. That was cool.
That is really cool. Rick, you were selling yourself short.
Yep.
Okay, can we use, can I run my own TensorFlow Lite model on this chip? And will it have to go through some kind of compression processor?
Not on the 10.6F, which, as I said, is specifically targeted for face recognition. But using our EIQ tools, you would be able to run your TensorFlow models on the RT1062, the kind of generic version of this platform. So the answer is yes.
Yes. And then can we use the SDK kit to develop our own applications on iOS or Android devices?
Well, the development kit is the face recognition development kit that Don was demonstrating is a microcontroller running FreeRTOS, and we complement that with this remote registration application that we have running on Android, and we also have a x86 PC version. What we don't have right now is an iOS version of that. So if that's the question, no, but I'm not sure that was the question. So maybe it'd be good to maybe have a follow-up discussion about this. Maybe I misunderstood.
Yeah, follow-up is a good idea here. So one last question. What about running other OpenVINO models? Is that possible?
Similar to my answer to the question about TensorFlow, with EIQ, you can work with a variety of different models. So it's basically bring your own machine learning models to our platform, and we can help you to use them on the NXP platform, whether it's an application processor like the i.MX 8M family, or whether it's a crossover MCU like the i.MX RT. We can enable you to bring your own models and do something useful on our platforms.
All right, great. So I did get a couple questions about whether we'll send out the presentation slides and the recording, and I do want to let you know that yes, they will both be available sometime next week when we get it on our website. It'll be available both through Future Electronics and NXP. So we can send you a follow-up email when they're live. So you can go ahead and view the recording and download the presentations. With that, I really want to thank you so much, Phil, Don, and Rick, for taking your time today to present.
Absolutely. Thank you.
All right. Thank you, everyone, for attending.
Thanks all. This is going to be the end of our presentation.